Let me show you how to be a good bee.
If there is one guest I don't need to introduce, it is Mr. Andrew Gelman. So I will refer you back to his two previous appearances on the show, though, because learning from Andrew is always a pleasure. So go ahead and listen to episodes 20 and 27. The links are in the show notes. In this episode, Andrew and I discuss his new book, Active Statistics, which focuses on teaching and learning statistics through active student participation. Like this episode, the book is divided into three parts. 1, the ideas of statistics, regression, and causal inference. 2, the value of storytelling to make statistical concepts more relatable and interesting. And 3, the importance of teaching statistics in an active learning environment where students are engaged in problem solving and discussion. And, well, Andrew is so active and knowledgeable that we, of course, touched on a variety of their topics, but for that, you'll have to listen. This is Learning Bayesian Statistics, episode 106, recorded April 2, 2024.
Let me show you how to be a good Bayesian and change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence and doesn't...
Welcome to Learning Bayesian Statistics, a podcast about Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the show, learnbayesstats.com is la place to be. Show notes, becoming a corporate sponsor, unlocking Bayesian merch, supporting the show on Patreon, everything is in there. That's learnbayesstats.com. If you're interested in one-on-one mentorship, online courses, or statistical consulting, feel free to reach out and book a call at topmate.io/Alex_Andorra. See you around, folks, and best Bayesian wishes to you all. Andrew Gelman, welcome back on Learning Bayesian Statistics.
Hello.
Yes, thank you for taking the time again, Andrew. You're almost a co-host now, and it's always an honor to have you on the show. Truly, it's your third appearance on LBS now, so for curious listeners, I definitely recommend episode 20, which was your first one with Andrew Gelman. Yes, you were here, and with Akivetari and Jennifer Hale. It was both your previous book, Regression and Other Stories, and then episode 27 with Marilyn Heidemans, where we talked about the 2020 U.S. presidential elections. We talked about the model you folks did for The Economists. So definitely recommend checking this one out because, well, I'm guessing this is going to be interesting also for this year's election.
We're working with them for 2024 as well. So we're trying to improve the model.
Perfect. Yeah. So it seems like you're releasing a book every 4 years just before the U.S. election.
I hope it won't be 4 years before our next book comes out. We're trying to finish our Bayesian workflow book, so we're hoping to get that. Hoping that will be done by the end of the year.
Well, yeah, definitely curious to check this one out. I think I also saw that you're working on an MRP update book. Is that still the case?
Yeah. There's I think Yajuan C and some Lauren. Kennedy and some other people are organizing this MRP book, edited book we're putting together.
Yeah, I will definitely check this one out.
Well, writing books is a lot of fun because you can write whatever you want because you're trying to communicate with the audience. When you write an article, you're trying to communicate with the reviewers who aren't the readers. It's a very weird indirect thing. It's, I guess, similar like if you're trying to write a TV show, you have to convince the TV network to produce the show, but they're not the people who are watching it. And articles are like that too. But a book is so simple. You just write a book and you're just aiming to reach people. It's very pleasant. I recommend it.
Yeah, I mean, I can see that it's something you really enjoy because you're such a prolific author. Yeah, I I use MRP quite a lot and often, so I'm definitely super curious to see what's gonna be in this book. I'm sure I'm gonna learn things personally, and that's also gonna help me teach MRP, which I'm doing from time to time. So thanks
Well,
a
we
lot for
we
doing
have a
that.
research project I'm very excited about now, which is integrating survey weights into MRP. So people do
Ah,
it
okay.
now though. They'll run weighted regression, or they'll do they'll have the model in stand and use power likelihood, but it's not really quite right. So we have what I think is a better approach. But that's not what you have me here today, right? Here I'm supposed to talk about our active statistics book, my new book with Aki.
Yeah, 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 exactly. I mean, we can talk about whatever you want, but yeah, the main focus is going to be your new book, Active Statistics, with Aki Vettari. And yeah, so maybe can you give us an idea of the genesis of the book? And thanks for showing up the book on the video.
Yeah.
So those watching on YouTube,
So
you've seen the book.
it's it's for people learning statistics or teaching statistics. So the story is that everybody says you want to do active learning. So students should be working together. Class time should be an active time for students to be thinking about problems, discussing problems. Um, I notice. So what the Okay, I teach a class based on regression and other stories, and it's 2 semesters, and each semester is 13 weeks, and each week has 2 classes, so that's 52 classes, and we cover the book. Um, every class is an hour and a half long, or I guess 75 minutes long, and each class I have a story, a class participation activity, a computer demonstration, some quick drills for students to work on in class, and then a discussion problem for students to talk about and think more about. I don't always have time in every class to do all of these, but sometimes I do, and I can always do most of them.
Yeah.
I found when I had been teaching statistics, I told stories a lot. But what happened, it's tricky to tell a story, partly because for not every teacher has a lot of experience, so they don't always have a lot of good stories. So our book is 52 stories, 52 class participation activities, 52 computer demonstrations, etc., one for each class. So first, these are 52 stories that are pretty good that I've come up with, or that Aki and I have encountered in our careers. So they're high quality stories. But also when I tell a story in class, sometimes it gets a little disorganized. So it worked good. It worked well to write the stories down. And for each story, we very explicitly say how it connects to the week's topic, the week's reading, and also how it connects to the course as a whole. And I felt that had been missing before. It wasn't hard for me to tell an entertaining story with statistical content, but I wasn't always making that connection with what was happening in class. So I feel that if you're a student and you want to learn statistics, you can read these stories, and they're great little stories. There aren't a lot of sources for statistics stories out there. Textbooks tend to have boring examples. They want to set it up like, here's how to turn the crank. Sometimes textbooks tell stories, but they don't tell them well, and I could give you an example of that in a moment. Um, there isn't really anything like this, and so maybe we should have just had a little book. Our book is how long is it? It's 350 pages long. Maybe we should have had just a book that was like 50 or 100 pages long with just the stories, because that already is great. Maybe it should have been several pamphlets rather than one book. Then we have class participation activities. These are things where the class gets involved. They're filling out survey forms, or they're doing an experiment on each other, or we do an experiment on them, or they're weighing bags of things and trying to get estimates. They're flipping coins. I love these. Deb Nolan and I had a book a few years ago, Teaching Statistics, A Bag of Tricks, which had a few activities, but this is a million times better. First, we didn't have 52 activities, but also these are lined up with the course. So they go in sequence. So they're not just fun things to do, they're things that line up with particular lessons. And I just love that. People tell me, they'll say, oh, I liked your book and I used one of your activities in one of my classes, and it makes me want to scream and like, throw something at the TV or punch the wall or whatever. I want you to do it in every class. Every class should have an activity, or at least most of the time. So that was a lot of effort because we had a bunch, but a bunch of them, like we just created from scratch. We need an activity for this. And that's really great. So that could have been its own pamphlet, another 50 pages. Then we have computer demonstrations, and I find that live demos are great. But if you try to do it from scratch, you get tangled in the code. So it's good to have pre-written live demos. And so that's like to say you should have a demo, and it's surprisingly hard. You create even something simple, simulate fake data and run a regression. You have to have good values of the parameters, or else you're not really demonstrating the point you want to make. If it has some curvature, how much to have. So we tested them out and did them in class, and so that way when I teach, I can always have a live demo, which is everybody's favorite part of class, and so forth with the others. And then we have some homework assignments, and we have some chapters at the beginning where we talk about how to set up the class and how to learn better. It's not really just for teachers, as I said, it should be for students. So that's what's in it.
Yeah, well, thanks a lot, Andrew. I already have a lot of follow-up questions for you. But something also you've told me in preparing the episode is that you have thought about the book in three distinct parts, right? So first one being the idea of statistics, regression, and causal inference. Then another pillar would be like using stories to explain statistics, and a third pillar would be the method of teaching with active student participation. So why did you choose these three different pillars, and how do you think they are helping an active learning of statistics, which is one of the goals of your book?
So teaching or learning is like a vector. It has a magnitude and a direction, and the magnitude is how hard you work to figure stuff out, and the direction is what you're learning. So yeah, I think applied regression and causal inference is super important. This typical audience for this book would be students who like took one statistics class. Maybe they already took statistics in high school or at university, took that one class where they learned about sampling and experimenting and estimation, intervals, normal distribution, stuff like this. This is all about using it, about going beyond that. So yeah, I think applied statistics is great. I want to teach regression about like the most important thing is understanding the model and being able to use it. Not so much the mathematical theorem about least squares estimation. That's important too, but there's other places to learn that. So yeah, the direction is that it's applied statistics. I think the magnitude is about how to make that work, how to get people to learn. And so most of the learning is not done in class, but at least if students are doing these activities in class, that the hour and a half or the 3 hours a week they're spending in class, they are already heavily thinking about it. I just like it's kind of horrible for the students because you really make them work. It's like teaching a foreign language class, right? If you go and take a usual class in college, you sit in the back and you zone out and you're like, oh, this is pleasant. It's like watching a movie, maybe. But if you're in a foreign language class, you're working all the time, right? The teacher's always making you talk and listen. If you lose focus for a second, it's difficult. Statistics is a foreign language, and you can learn by speaking it and practicing it. So I think it's important in class to be able to do that. Or if you're studying at home, to have these activities and stories. That there is it's, and of course, the computer, I'll say like my computer code's pretty bad, so that's good, right? Because that's like student code. It's all crappy code, so it's realistic. I know it's not the world's cleanest always, I would say, but it runs, but like maybe it doesn't all run either. It ran when I wrote it. Um, it's supposed to be when I do code demos in class, what I like to do is actually type in the code, not copy and paste it. So that's modeling how someone might do it. So we try to keep them short enough that you can do that. Um,
Yeah. Yeah, thanks a lot. I see what you're doing. And I really appreciate it because that's also helping me in my own, teaching philosophy, because I do find do have the same experience where the students who end up learning the most are usually the most active ones. Um, but then the main question is, okay, how do I make them all active, or at least give them the opportunity to all be active? And that's
yeah.
really one of the
Well,
hard thing that I
yeah,
do.
when I teach, I make them talk. Like even it could be a class with 50 or more students, but I'll tell the
Hmm.
story and then I'll pause and then say, well, what do you think? You talk to your neighbor about this. And I look and I make sure they're talking. And if they're not talking, then I walk over and say, I go like this to them. And if their computer is up, I look. And if they're on their, social media, I ask them to close their computer. And if their phone's out, I ask them to close their phone and so forth.
Hmm.
So and the funny thing is, as a teacher, that's hard. It's easier as a teacher to just talk and talk and talk and talk. Like I'm talking now, I'm just talking. It's
Yep.
easy to
Yep.
talk, and you have complete
Hmm.
control over it. So that's why I really needed to structure this in this way.
Hmm.
That was
Hmm.
my original motivation for all of this, was that many years ago I was teaching a class and I couldn't make a class. I had my co-teacher, not my co, another faculty member in the department who was teaching the same level class, teach my class, and then I went and taught hers, and she said, "Oh, your students were just dead." And then I talked to her class, and they were so lively, and I realized not that she was lucky, but that they had been in the habit of participating in class. She's just a natural great teacher. I'm naturally not a good teacher, and so I do this shtick in order to get them involved. And then I just wanted to do it well. I want to tell stories, but I want to be able to make the point that I
Hmm.
help to learn it.
Yeah. That's interesting because me, when the teachers were doing that to me, it's because I was talking too much. That happened quite a lot. Maybe that's why I have a podcast now. But apart from these philosophical considerations, um, that's very interesting. I'm gonna try that in my own classes. The thing is, I personally teach a lot of online courses, and so I cannot
Oh,
meander and see the screens. So that's gonna be hard.
yeah, it's tough. I remember when I was doing the class over Zoom, and you could try to put them in a little room so they work in pairs. But yet, if you can't see them doing it, I think there is some online conferencing software where you can actually see the pairs and
Hmm.
or the small groups. But I don't know the full story with that. But I'll give you an example. I mean, there's something. One of the things that's difficult, I don't know there's any answer about this, about the stories, is that if they're too if they're too simple, that's boring, but if they're too complicated, then that's not good either. One thing I like to say, like I want to send the message that statistics, how did I put it in the book? I had a slogan, um, that statistics is hard, it should not feel tricky. So
Mm-hmm.
I don't like those. I don't like this. I like statistics stories with a twist, but I don't like the kind of stories where the message is this is just hard. Like this, like at Monty Hall problem. I hate that because it's just so confusing to people. Like, what's the lesson that you're teaching, right? Like, this is really, really confusing. I don't want to teach that. But here's an example, and this is a very standard example used in United States statistics classes where we put another twist on it based on the recent literature. So this was a survey that was done in 1936 by a magazine called the Literary Digest. And they did a very famous in statistics books example. They did a survey for the presidential election, and it was
Mm-hmm.
the presidential election was Franklin Roosevelt running for re-election against somebody who wasn't Franklin Roosevelt. So you kind of know who won that election. But in
Mm-hmm.
their poll, actually, Franklin Roosevelt was going to get destroyed. They did a poll with They surveyed 10 million people, and 2.5 million of those responded. And out of that, it looked like Roosevelt was completely getting smoked. Well, there were two things happening. One is the 2.5 million respondents were not a random sample of the 10 million people. Second, the 10 million people were themselves not representative of Americans because it was from lists of people who own cars and things like richer people. So it wasn't a representative sample, and usually it just stops there. But that's not a good place to stop for a couple of reasons. One of which is, what lesson are you telling people? If you don't have a random sample, your survey's no good. Well, unfortunately, no surveys are random samples. I mean, no surveys of humans, no political polls are. So the message would be, oh, you can't ever trust any political poll. Well, that would be a mistake, because political polls, even when they're off, they tend only to be off by a couple percentage points. So what goes on with political? Well, so let's look at this survey. The first thing is that the same magazine had done the survey in previous elections and it had worked well. So they had some track record. It wasn't as dumb as it sounds. Um, the second thing, and this is something that two statisticians recently looked into, I was able to take advantage of their work. So Sharon Lohr and Michael Brick had written a paper on this 1936 Literary Digest survey where they realized that, or the data from the survey are actually somewhere, like they're available. Um, the and one of the survey asked people who they would vote for, but it also asked who they voted for in the previous election. So you can adjust for that because you know the election outcome, the previous election outcome. Well, it's not perfect because not everybody voted in the previous election, but it's pretty good. And when you do that adjustment, you find that Roosevelt was supposed to win. Well, it's not a perfect adjustment. It's still quite a bit off. It's even after doing this adjustment, it's still not a representative sample. But now we've changed the lesson from, hey, it's not a random sample, you fool, blah, 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 to, hey, this sample is not a representative sample, but statistics can be used to adjust it. Look at this. But the adjustment is imperfect. So it's a more subtle message. Well, it's trickier to teach. That's one reason why I like having the story written as a story very clearly in the book, because then the student or the teacher can read through the whole thing. If you're a student, you can read it through, and if you're a teacher, you can first read it before trying to teach it. And there it is. It's on page 36 and 37 of our book. There's a copy of the survey form, and it's literally like the description takes up one page of the book. Almost all of it is a quote from Lohr and Brick because they're the ones who did it, and then a little discussion of how it relates to the class. But everything is like, these stories are all like that. Like you have to balance it, and it's tricky. Like there almost should be another booklet of the really simple stories that we didn't put in because they were too boring for me, but maybe still interesting for the students. I don't know. We went back and forth. It's structured from beginning to end of the course. So there's there's a couple introductory chapters, and then there's 13 sections for the first semester and then 13 sections for the second semester. So most of the book is 26 sections. And in each one, we have the story and the class participation activity. And we went back and forth about whether to do it that way or whether to put all the stories in one place and all the activities in one place. And I don't know. Now I'm thinking I wish we had done it that way. But Aki and I went around and around on this a million times. You don't need to hear about this. I wanted it to look right. The thing is, if you opened up at random, you might get a page of homework assignments, and then it might look like a textbook. So it all kind of looks the same. So maybe if we had separately done the different things, it would have, then there'd be a whole section of stories. But when you're teaching, it's convenient that it's in order because you just go to the week of your class and then you can see what to do that week. So I used it to teach.
Yeah, and I really love also your focus on the stories, right? I see it's definitely a theme of your work recently, and I really love that because I think it also puts an emphasis on the fact that statistics is not done in a vacuum, right? And it's also done like by humans, with their biases and also their motivations and so on. And I found that way more interesting, way more realistic, and also that captures more the imagination of the students rather than teaching them theorems and formula, which often is quite intimidating to a lot of them. So yeah, I
I
do
hope
appreciate
to.
that that
The
part.
stories are like all things that I can personally relate to. Like either
Hmm.
they're things that I was either it's research I was involved in, or it's something close enough to what I do. Like I'm interested in the question being asked. Um, it's yeah, they're and the same with the activities. The activities have a lot of simulated data. I'm a big fan of simulated.
Yeah, you are. In a lot of your books, you talk about that. Do you wanna do you wanna talk a bit more about that, or you think we've covered already
I
the
well
idea of
the
simulated data in the regression and other
Well, I'll
study
just
episodes?
say briefly that I think we are, as statisticians or computer scientists or whatever, we're used to the idea of here's a data set, let's see what we can learn. But science, I mean, sometimes we proceed that way in learning. We want to understand the world. You're curious about something. Someone gets a bunch of data from basketball or whatever, and then you play around and see what you can get. So that happens. But often things are more directly motivated. Like if in a public opinion poll, you're really starting with the question. Um, when in demonstrating a method in coding examples, it's super great to have simulation, partly because it's the dual problem, right? If I simulate the data, then I fit the model, I can check, I can see if the parameter estimates are similar to the true value, but also just the act of simulation is the time reversal of the act of inference. So it makes sense to show the forward process too. And I
Yes.
think it's kind of
Yes.
a bit of a power thing as a student. Look, I can simulate data. I can make fake data myself, right? That's
Yep.
that's something that can
Mm.
be done. Traditionally, we do simulation when we're teaching probability. Like you'll teach the central limit
Yeah.
theorem by simulating draws. Um, but like just a lot of examples come up. It's very simulation is a kind of it's like a universal solvent. Like for example, one of our discussion problems in classes, I show them data from some regression, which is just based on real data. And I don't remember the example, but something where there's some treatment effect, which you maybe expect is positive. And maybe the estimate is, let's say the estimate is zero point 0.3 and the standard error is zero point 0.2. And so then I say, and it's based on 100 data points. So then so it's estimate is zero point 0.3, the standard error is zero point 0.2. So I'd say, how large a sample would you need to get a result that's two standard errors away from zero? That's statistically significant, a term that I don't like to use, but of course they need to know how it gets used. So you'd say, oh, well, the standard error is 2, but really the standard error would have to be 1.5 for it to be two standard errors away from 0. So the sample size would have to increase by a factor of 2 divided by 1.5 squared. So you take 2 over 1.5 squared, and that's, so you can do that, and you say here 2 over 1.5 squared times 100, and that's 177. So I'd say, well, you need a sample size of 177 to get your estimate to be 2. So work that out. That's wrong. That's not the correct answer. Because if you redo a study with 177 people, there's no reason to think the point estimate will be the same. In fact, like the whole point of saying that the estimate is less than two standard errors away from 0, and you don't know whether to believe it, somehow the whole point from a Bayesian point of view, the point is that it's likely to be closer to 0. From a classical point of view, the idea is that you can't rule out 0 as an explanation, and 0 is like typically a privileged value there. So if you're replicating a study or even doing it longer, you would have to, the answer depends on the true treatment effect, not on the coefficient estimate. And well, that's harder, right? But the point is you can like show that with a simulation. If it's based on real data, it's trickier to show because what are you doing? But if I then do a simulation and then I say, well, look, let me try simulating 100 with this true treatment effect, and then I see what I get. And I say, well, shoot, I didn't get a treatment effect of 3, zero point 0.3. I was supposed to, you have to keep doing it, and then you realize you're selecting just some. So to me, it brings it to life. The applied point gets demonstrated in a way that's harder to do with just one data set.
Yeah. Yeah. I really love that. I agree. And that's also something I tend to use on a lot of questions people have on, A/B tests, settings, things like that. There's a lot of questions about the sample size, saturation, things like that. And I find, personally, I have to do the simulated data studies to answer these kind of questions. Like I'm bad at like remembering, all those rules are awesome. Like, okay, like let's do that kind of studies with simulated data, and that gives
Oh,
me a
yeah.
way better idea.
So, in a completely unrelated topic, I can tell you about our two truths and a lie example. That's a
Oh yeah.
demonstration we do. I'm mentioning that
Mm-hmm.
partly because I writing a book is like writing 100 articles. So, like at one point, I thought, well, maybe I should publish these as 100 articles. Because each story could be, well, that just takes a lot of work, and like maybe more people will read it in book form. So I didn't do that, but I did one of them. I did one or maybe I did one or two. I can It takes a while to publish an article, and for the bad reason that it's just formatted in a different way, for the moderately good reason that you need to explain more if it's in an article rather than a book because you need the context. For the pretty good reason that you're forced to that like you have an opportunity to expand because you have more space. Like in the book, I can't take up too much. I can't have each thing take too long. And for probably the biggest thing is you get useful reviewer comments and people point out problems. Anyway, so the one of the activities I did write up as an article was two truths and a lie, and I gave a link to the article version, which is longer than what's in the book. But I love this story. Okay, is the story of how it came out is that there's this game which did not exist when I was a child, but I don't know if they do it in Europe. It's popular in the US as like
Mm-hmm.
kids do it as an icebreaker in class. You'll have a group of people, and one person is the storyteller, and this person tells three things about themselves. Two of them have to be true, and one has to be a lie. And then the other people discuss and try to figure out which is the truth or which is the lie. So it's such a fun example, such a fun activity. I like to use it as an icebreaker in my statistics class, but it has no statistics content. I mean, it is because there's uncertainty, but what do you do with it? So I thought about and thought about, and well, I decided to put it in the second semester. I was ready for a good icebreaker, and the second semester started with logistic regression. Okay, I can make it logistic regression problem because you can say what's the probability you get it right. Uh, what's the probability you guess correct? But then you need some predictor. So predictor. Well, you can have when you guess, you also have to give a certainty score, some number between 0 and 10, representing how certain you are that you're correct.
Mm-hmm.
Then it has to
Mm-hmm.
be done in groups. So I figured it out. You divide the class into groups of 4. Usually we do pairs, but this one 4. Each group you have one student is the storyteller, tells the 3 statements. The other 3 discuss together and then come up with a guess of which they think is true, which of them they think is a lie, and a certainty score. So write the certainty score down on a sheet of paper, then find out whether your guess was correct and write that down too. So they find out. Then there's 4 of you in the group, so you rotate. Then the next person does it. So as a result, as a group, each group has 4 certainty scores and 4 correct or incorrect, answers. So they have 4 numbers. They have 8 numbers. First 4 numbers between 0 and 10, and then the 4 numbers which are zeros and ones. And so, by the way, when you do this, I have a slide prepared or I write it on the board, the exact instructions. You need to give you can't just tell it. People aren't paying attention for 1 second. I'm just doing this for you and that thing, but actually have the instructions there. Then did this thing I discovered a couple of years ago. It's putting things on Google Forms. So
Mm-hmm.
live in class, I create a Google form. I open Google, type it in right there. This is also it's a power thing for them. Look at this. I didn't have to prepare this. I type the Google form. I put question 1, certainty score, make it a response from 0 to 10. Question 2, yes or no. Did you get it? Was your guess correct? So with each group, I want you to go. Oh, and then we use tiny URL to get a URL. And then for each group, I say, pull out your phone or your computer, and one person from the group enter your 4 data points. So we set it up with 4. So there's actually 8 responses. The first one, the second. Then we get the data. It takes them a minute to type it in. Then I have it all prepared. I've done it before, right? So I have the code ready. So I go to the Google page, I download it, I put it on the desktop. It's not even my laptop, it's just a computer that's in the classroom. Then I open R, I read it in, and I have the code prepared so I can do it. And then we can make graphs. So but then I did something I always like to do. I set it all up. Okay, we have the data. I type in the code for logistic regression. Again, I pause. I say, well, write the code with your neighbor, what the logistic regression code would look like. So, and then I do it. And then I type it, and then I do display, of the fitted regression. And before hitting carriage return, I say, this is what it's going to look like. There's going to be coefficient estimate, standard error. What are they going to be? You and your neighbor have to try to guess what the estimate and the standard error are going to be. Well, the standard error is tricky. Like, that's hard. So just guess what the estimate will be. And so then I have them do it. I go around the room. I make sure they're all drawing the curve. And then I have someone go on the board and draw what they had done. And then I ask people, do you think this is reasonable? Do you think this slope is reasonable? Now, what do you think the standard error will be? Do you think this slope will be more than 2 standard errors away from 0? Then you fit it, and you have the scatter plot, and they can see, and they've thought about it, they've committed to it. So that's logistic regression. But when I wrote up the article, the people in the journal said, well, what about other classes? And then I realized you can use this to teach measurement, you can use it to teach experimentation, like all sorts of things. You could do a lot with that. But I felt so satisfied because I felt like it was just created out of nothing. I wanted a 2 truths and a lie activity, and now there is one. So that was
Mhm.
it felt so good to have created it. Now I want everyone to do it, because now that
Yeah.
I created this beautiful thing out of nothing, it did not exist. Anyway, I'm very happy about that.
Yeah, I love that. I'll definitely try that in my own classes. Seems like a good thing to do on the first or second class, isn't it?
Right, exactly. Now the point is that you're killing 2 birds there.
Yeah, yeah. No, that's super cool. Definitely gonna try that, for sure. So, and it's like I have a commitment device now. I have officially, publicly committed to do that. So I have to do it and then come back to you, Andrew, to tell you how it went.
Well, the other thing you can do is there are certain fun psychology experiments from the literature that can be done in class, because things
Uh-huh.
that have very large effect size, like some of the classic like Tversky Kahneman
Mm-hmm.
experiments of cognitive illusions. Like
Mm-hmm.
we have one of those examples too. Like you can do it live in class.
Hmm. Yeah, that sounds also super cool. Uh, and is that so? I also saw in preparing the episode that you have a flipped classroom. Like you emphasize a flipped classroom environment, and I don't think I've ever heard you talk about that. So could you explain what this approach is and how you think that enhances the learning
So
applied regression and causal inference?
I think, to me, the flipped classroom is pretty much the same as traditional high school classes, high school math class. So if you take math in high school, you have uh, a book you're supposed to read, and there's homework assignments. Usually you read just enough of the book to allow you to do the homework assignments. Then in class, the teacher does a couple things in the board, and most of the time in class you're spent working on problems in pairs or small groups, and then people go up to the board and share their answers. And that's kind of what I think should be. So that's the model of, so it's very traditional. The flipping part is, I don't have videos. I guess I could, but I don't. Aki has videos for his classes. I have, but the flip part is the reading, right? So I'm
Hmm.
not lecturing because they're supposed to have read the book. Now, what happens, it works only if you have a book that you can lean on, but I think that's very important. This semester, I'm teaching an applied statistics class, teaching some multi-level modeling and some other things. My book with Aki and Jennifer on advanced regression and multi-level modeling doesn't exist yet. I mean, it's supposed to be the updated version of my book with Jennifer. I couldn't quite bring myself to teach out of my book with Jennifer just because the code is old. But then I don't have a new book. And so as a result, the class I'm teaching this semester, it's fun. I think the students are enjoying it, but it's not going as perfectly as it could because I can't really do the flip thing because I end up spending a lot of time in class. Like my computer demos typically end up being me doing the homeworks, working them out, the homeworks that were
Yeah.
just due, which is fine, but it's not, they're a little bit more elaborate than. Ideally, I think computer demos would be shorter. They don't have enough to read before, so I end up spending a lot of time lecturing. I think I spent most of today's class just talking. I felt a little bad about that. I don't know. I think it's still fine. It's still a breath of fresh air compared to other classes they're taking. I'm sure if all the classes were like mine, then that would be horrible. But an occasional class that's like mine can be good. I think in general, students like more organization. A book is better. Even my when I teach regression, other stories, that's super organized, but it's not always what students want because they want a set of methods and formulas and theorems and so forth. So I'm not
Hmm.
always giving people what they want anyway. I think they're really looking for very clear. I don't, I have this thing, the goal is to be fluent in the foreign language, but I don't think people usually think of it that way. I think that they're looking for something different. But what that means is that it puts a special burden on me to be super organized because if I'm not super organized, then I think students will not see the point. So my class
Hmm.
this semester, it doesn't use the book. It's not as flipped as it could be. I still have them talking with each other in class, but it like not having the flipped classroom makes it a little more of a passive experience for them. And then when I do have
Hmm.
them talking, they're often just talking to each other saying, "Oh, I have no idea what's going on here." It's like, "Oh, good that I know that, I guess."
that's that's true. Um, yeah, and I mean, I do relate to this idea of the, you know, getting fluent in a foreign language. That's actually also a metaphor I use quite a lot to people who are curious about what the work of a statistical modeler is. Um, and that's funny because, like, there's that weird human brain bias of just thinking that, someone who is doing something that looks hard to you, or they must have been good at it since the beginning. And it's at least for me, couldn't be further from the truth. It comes from a lot. As you were saying, I think you were saying like learning is a vector. It's like magnitude and direction, right? So definitely magnitude is very important for me each time I learn something. Um, and and often is I'm saying, yeah, well, you have to, you have it. It looks hard because you have to learn kind of two languages: the language of stats and the language, like the actual programming language that you need to do the stats. But it's just as any other language, you need to talk to people in that language, and with time, you'll see your brain just getting there. Um, so it does go through to people, but at the same time, they need to see some results along the way because otherwise the motivation is gonna fall down. Um, so it's always that needle that's a bit hard to thread in my experience.
Yeah, well, I like this book. See, I seriously think this book is just fun to read. Although, as I said, I kind of I kind of wish I had separated it out in a different way because I do feel when you open it at random, you might see some code or you might see a homework assignment or you might like it's not always clear what like you're not necessarily opening into a middle of a story. And so like
Mm-hmm.
homework assignments don't look like fun and code doesn't look like fun. So um I don't think I realized you don't see the book until it's a book. Like before that, it's this PDF on the screen,
True.
and
True.
it has a different experience that way. And Aki's gonna
Mm-hmm.
kill me that I say this because we went back and forth, and
Yeah.
but like now I think we really should have. Of I really think we made a mistake by not doing it the other way because I think it would look a lot more fun that way if like all the stories were in one place and all the activities were in another place. I'm really feeling bad about that. I still love it. It's just we just have so many fun things. Oh, and then we for the final exam we made it's multiple choice. So what I do is I have four or more questions per chapter. So it's like it's the exam has so there's 12 chapters for the fall and 12 for the spring. So each chapter I have four or more questions. What I do is I randomly sample one per chapter and give that to the students as their practice exam. Then I randomly sample two per chapter and give that and make that the final exam. So therefore,
Mm-hmm.
by construction, the practice exam is representative of the final exam because they're two random samples from the same population. So I think that's great to be able to do that. Now, of course, all the homework, all the problems are now in the book, although without the answers. So, like, you'd have to figure out like which it is. But in theory, someone could read through all of those. But of course, the usual story is if someone really goes to the trouble of reading through all of them and figuring them all out, that's probably good anyway. So I don't mind if they didn't do well on the exam. Um, but it took a lot of effort to write. These multiple choice questions are hard to write, but I think they're
Yeah.
easier to grade, and I think they're testing something that's a bit more focused. It's very easy to write open-ended questions and not know what you're testing.
Hmm.
You know,
True. Yeah. Yeah. It's a bit more like, yeah, it could be a bit more like astrology, right? Where you always find something you're satisfied about.
yeah, exactly. And it also encourages a certain behavior among students to just keep writing and trying to like touch all the bases.
Mm-hmm. True. Yeah. Yeah. Um, as a pure product of the French educational system, I can tell you open-ended questions are like my bread and butter. I've been I've been trained at that a lot. So each time I have to answer that,
I
and like I've a weird feeling of familiarity, and at the same time I like it and I dread it. So that's weird.
Many years ago, I taught a class in France, and the students are supposed to do projects, and it just happened. Like, yeah, everybody's busy. So one of the groups they did nothing. I mean, they turned something in, which was pretty much they had just like it wasn't plagiarized, but they had just copied stuff from the internet. Like, they just literally copied some images, and it was essentially nothing. So I talked to the the head instructor of the class. I said, well, I want to give them a 2 out of 20 on this. Like, I guess, I maybe I don't give them 0 because they wrote a sentence or two, but like, can I give them a 2 out of 20? He said, well, yeah, you're giving the grade. I said, in the US, if you want to give someone a low grade, you have to ask for permission because you're afraid they might sue you or complain or something. But he said, no, in France, you can give people, 2 out of 20. They might even think it's a good grade. So it is a different French system is a little more rough in how the grading goes. I
Yeah.
remember that.
Uh, yeah. I mean, it depends. I don't know at what level you're teaching, but if you're teaching in especially in the class préparatoire, so that weird stuff we have in between high school and universities.
These were graduate students.
Yeah, yeah, yeah. So you can definitely do that. I know I like my first philosophy dissertations when I started the class préparatoire were absolutely a disaster. Um, that was like I think I got 4 out of 20, something like that, and that was
Like it
not
is
even in the
like
worst grades.
you know how like in gymnastics, like it's like 9.8, 9.9, 9.93, like that. Like the grading system did that. But statistics it's really hard. Like I think real world problems I wouldn't give myself a 20 out of 20 in my analysis, because if you're doing an experiment in political science or psychology or economics or an observational study, everybody knows about identification being difficulty, but there's a lot of other difficulties. So usually if you're doing a causal study, you want to have between person comparisons, or in political science or economics, it would be called panel study. You want to have, ideally you do the treatment and the control on each person, but if you can't do that, you want to make comparisons. That's super important, partly for statistical efficiency and for balance. And it's also kind of a measurement issue because measurements can be biased, and biases can actually, like the treatment can affect the measurement bias. And you can even have treatments that affect the measurement bias without affecting the outcome. It's so naive view that if you just give randomly assigned treatment and control, that you have a kosher estimate of the causal effect. That's not really right in general, because that assumes that the measurement bias doesn't vary with the treatment, and that's often a mistake. So you really want to have panel structure or repeated measurements within person designs. That means you want to start fitting multi-level models. So if you don't have a lot of observations or a lot of groups, then your inferences could depend on the prior, which it really does. Like you could act really tough and say, "Oh, I'm really tough, I'm not using a prior," but then it just means your inference is really noisy, and that's not good either. It means you can get bad things. And then what predictors to include? In theory, everything should be interacted with everything, because otherwise that can induce bias. But in practice, if you do that, you have a lot of coefficients running around. So even the simplest problems are like there's no right way of doing it, which gives me a lot of sympathy for researchers. And I know here we're not talking about like the crisis in science, but I'll say that like sometimes people will say that you should pre-register your design and analysis. And I think that's great, but it's not going to solve a lot of problems, because if I don't know the right analysis to do, I don't know what I'm supposed to be pre-registering. It's really difficult. It's not, we can't just do better science by just like there's this phrase, questionable research practices. Like it's not like you can just stop doing questionable research practices and everything will be okay. It's not clear. Doing it right is not just the absence of making mistakes. It's very difficult. And so when we're teaching or when you're learning, I'll say, because I really would like our book to be read by people who are not necessarily teaching a class, but just want to learn the stuff, that when you're learning, there is this weird thing where you have to learn the skills and at the same time realize the limitations. And it's hard to teach in that way. It's not like it's easier to teach something like physics or chemistry, where you say, here's what we're doing, and then later on we're going to tell you why these ideas aren't correct, and we're going to do something more elaborate. In statistics, it's hard to reach that like plateau where you say, well, here's the basics, learn the basics. Once you're learning the basics, you keep seeing all the problems at the same time. So it makes it very fun to learn, but also challenging.
Yeah, true, true. Yeah, and actually that makes me wonder, how do you think, so for people who are gonna use your book for teaching, so instructors, how can they adapt the materials for different educational settings, like such as introductory course or more advanced courses?
So it's set up for this class on applied regression and causal inference. So if you're teaching out of regression and other stories, it's very easy. It just gives you a whole template for a 2-semester class. I've also taught a 1-semester version where I just do one activity and each week I have 2 of everything. So instead I just pick one story, one activity, and so forth. That's what actually I did last semester. If it's a more advanced class, and I would say, or a more basic class, if it's a more basic class, I think it still pretty much works. You just have to simplify. Like the code demonstrations are going to be way too complicated for a more basic class. But I think the stories work and the activities work. You just maybe have to like change it a little. So in 2 truths and a lie, you wouldn't do logistic regression, but for example, you could still make a scatter plot, and you could still like compare the probability, the proportion of correct guesses for people with certainty scores higher than 5 and lower than 5. You can adapt it. I think a lot of the activities are like that, and the stories. For a more advanced class, I think again, it works in the other direction that this can be a starting point. You give the story and also people have their own stories. So reading my story might help you as a teacher think of your own story and tell it in the same way.
Hmm. Yeah, okay. Yeah, I see what you mean. Um, I'm thinking randomly, it sounds like you would be interested in Andrew at some point in writing some fictional stats-based stories. Something like, I think Carl Sagan, right, did write some science fiction. Would you be like, do you see yourself doing that at some point so that you are forced to maybe not use any modeling or things like that in the book and you have to completely only tell stats through the stories angle?
Well, well, fake data for sure. I did have an idea. I was thinking about having a book where it's all like it's learning statistics through fake data simulation, where everything is just you just start with some very simple things, like everything. That's like the gimmick, right? The gimmick is here are all the principles of probability and statistics, and you're not allowed to use any real data. You're only allowed to do fake data simulation, and you can cover a lot, like all sorts of things. The attenuation of the treatment effect when you have measurement error in your predictor, and like anyway, all sorts of things you might want to cover. You could do that way. So I thought that would be fun. Maybe a fun future book. I mean, fiction. Jessica and I wrote a play. Jessica Holman and I wrote a play, Recursion, which is fiction. It has a computer science theme. It was
Yeah.
performed at a computer science conference recently. So I guess, yeah, we have written fiction. It didn't really have, it had some statistical principles in there. There were some, it had some, like yeah, I think we had some line where one of the characters talked about their code being beautiful, and then somebody else said, code that runs is beautiful. And then somebody else says, code that runs and you know it runs is beautiful. So that's like some workflow principle. So we were able to put in some of our thoughts about statistical workflow in fiction. So yeah, it's possible.
I knew it. I knew it. Yeah, I'd love to hear that. I'd love to hear that book. Read that book. And I was saying here because I think, and you could even record the audio version yourself. I think that'd be awesome.
Yeah, well, that
I'd love to.
performance apparently went well, but they didn't video it. So we want to get it performed somewhere else. We see.
Same. Yeah. Yeah. Well, let's try that. If there is one day, if I manage to do a live LBS dinner, that play should definitely be performed at that dinner. It's like that's a must. Um, Now I'd like to ask you something about I know a topic that's dear to your heart is visualization and its tied to understanding, because the focus on visualization is a key aspect of your book, Active Statistics. It was also it's also a key aspect of almost all your work. So I'd like to hear your thought about that. How do you think visualization aids in the comprehension of statistics and custom models?
Well, so I'll talk about two things. First, visualization in teaching, and second, visualization in statistical, like applied statistics. So with teaching, I think like I think the deterministic part is usually the more important part of the model. So I want people to be able to visualize what is the line y equals a plus bx. What does it look like if I have an interaction? What would the two lines look like? What does the logistic curve look like? I I don't, I think it's a mistake when statistics books start with things like a histogram. Histogram
Mm-hmm.
is not fundamental. Actually, it's very confusing. I used to do this assignment where I would say to students, gather between 30 and 50 data points on anything and make a histogram of it. And about half the students would do it. Like they might gather data on 30 countries or 50 states, or they might take 30 observations of something and make a histogram. Um, the other half would make a bar chart showing their 30 observations in time order. So it would be like, basically it was a time series, except it would just be displayed in bars because it was a histogram. And so like you see, the problem is that a histogram is supposed to convey a distribution, but what people are getting out of it is it looks like a bunch of bars. And half the students didn't get the point. The concept of a distribution is very abstract because the height of the bar represents the number of cases or the proportion of cases. And
Yeah.
it's not like a scatter plot. I think it's actually more intuitive. But I noticed that statistics classes were always focusing on that as if, because, a histogram is one dimensional. What could be more simple than that? I think a time series is really much more basic. So when it comes to plotting data, I think we really have to get a little closer to what we care about. A lot of just stupid stuff like box plots. I hate that. I hate that stuff. And it's like, I don't see, it's just like people just do things that are conventional and I think are absolutely horrible. But anyway, all this focus on distributions, I think the deterministic part of the model is more important. And so that's what I try to convey. One thing I noticed is that students will learn stuff if it's on the homework and on the exam. They won't learn it just because it's on the blackboard in class or in your slides. So I found that when I did my work, I often make sketches of graphs. And so I have homework assignments where you have to make a sketch, sketch what you think it's going to look like, then fit the model. Because if you don't ask people to do that, they won't. So teaching has to be like, you want people to actually practice that kind of workflow. So then I had something else to say, but I won't. We can say it another time about statistical graphics. It's already kind of going on a little bit. So if we ever talk about statistical graphics again, just ask me to tell you what I think is this really super important aspect of statistical graphics within statistical inference, and I'll tell you about that.
Okay, perfect. Well, I will definitely tell you. Do you still have time for one or two questions, or should we?
Yeah, sure. I have time for one or two questions. Sure.
Okay, awesome. So let's continue. I'm curious about that. How do you handle the distinction and or the transition from regression analysis to causal inference? How do you navigate these two topics in the classroom setting to ensure that students grasp both concepts effectively?
So I overlap. So I start talking about causal inference at the very beginning partly because they can't avoid it. So we'll have a regression, like maybe you fit one of the examples we use in regression. Other stories is predicting from some survey, predicting earnings from height. Taller people make a little bit more money than shorter people, and then you can throw sex into the model, and men make more money than women. Taller say, how do you interpret the coefficient of height? Well, if you're for every inch taller, you make this much more money. So that's not right. You have to say, comparing two people of the same sex, one of whom is 1 inch taller than the other, under the model, on average, the taller person will be making this much more money. So what are the things you need to say? You have to say comparing, because it's all comparative. There's no causal language. You have to say on average. You have to say according to the model, and you have to say not controlling for blah blah blah, but comparing two people who are the same in these other predictors. You're not holding everything else constant. You're doing this comparison. So I do this. I have a drill in class where they have to do it. And then they laugh. It's like a joke because I say, here's a regression. Explain each coefficient in words. And they say, like, what's the coefficient of the intercept of this model? Well, it's like I'm predicting something as a function of time. So this says, in the year Jesus was born, that's the intercept, right? At year 0. Right? So is that interpretable? Well, maybe it's interpretable. If you have a time series going from 1900 to 2000, maybe we're not particularly interested in what happened when the year Jesus was born. That's a bit of an extrapolation, but that implies. But same with the coefficient. So it's like a joke in class. It's a fun inside joke we have in class that I'll ask them to explain the regression coefficient, and they have to say it without using the wrong language. And it's like, it's like the game you play as a kid where like you're not allowed to say the word no. If you say the word no, you lose. You have to figure out a way to decline. Will you give me your cake? I choose not to give you your cake. You know, like I choose to do something else or whatever. So similarly, you're not allowed to use this word. And so right away, we're introducing the idea that causation is important. And then when we get to causal inference, well, we have regression already. So we use that not for controlling for things, but for adjusting for things. So we've already done non-causal examples, like the survey example, where we adjust for differences in order to post-stratify it. So then it fits in. So there's a lot of specific things about causal inference, but we first half is we don't cheat at the beginning. We don't pretend to be causal when we're not. Then when we get to causal inference, we make use of what we've already done rather than treating it as an entirely new topic.
Hmm.
My little particular pet thing is that the usual way causal inference is taught is there's an outcome and a treatment. Right? Some people get the
Yeah.
treatment, some get the control. I say the basic is there's pretest measurement, a treatment, and an outcome, and that's in time order. So it introduces time. You don't have to have a pretest, but you should. And so it's good practice, but also it puts you into the regression framework already, which is
Hmm.
helpful.
Hmm. Yeah.
So sometimes things that are too simple are harder to understand. A little context can help.
True. Yeah. I found also the directed acyclic graphs do help quite a lot in teaching the causal inference concepts, especially because you can then marry that with the graphical representation of the Bayesian model that you can come up with. And then you use simulated data. You can come up with the model, then write the model, and then just simulate data and see what the model tells you. And if it's able to recover the true parameters, I find these fits pretty well together in the workflow.
Good, good. Yeah, I
Mhm.
think there's a lot of different ways of teaching these things and using these. There are different frameworks that can work well, and I think that's good that that's the case. That
Mhm.
there's more than one way of explaining things and understanding
Mhm.
things.
Mm. Yeah, true. Um, Actually, I'm curious, like in your, based on the methodologies and also the philosophies that you present in active statistics, how do you see the future of statistical education evolving, particularly with um, the advent of new technologies? And how do you see that play out in the coming years?
I don't know. I mean, I'm still unhappy with how statistics is usually taught. So introductory statistics, it's really been like the textbooks now are almost all pretty much the same as the textbooks from 40 years ago. I mean, they look
Mm-hmm.
different, but it's based on this thing where they teach like there's this they teach these distributions and so it starts by focusing on variation, which I think is not even really quite right, like, and then because it's not really focusing on the questions that are being asked, it's really focused on the error term. And then
Mm-hmm.
there's all this stuff about the sampling distribution of the sample mean, which is just kind of weird. Nobody cares about the sample mean, and or rarely do. It becomes very abstract and hard to follow, and then there are these like confidence intervals, like a huge amount of work to create these little summaries that you don't really want to be using, along with a bunch of messages. If you don't have random assignment, you're screwed. If you don't have random sampling, you're screwed. Then at the end, there's some stuff like regression and chi-squared tests and things that people do, and it's just kind of a disaster. I really hate it, and I would like things to be much more focused on the questions being asked. It's hard for me to think exactly how to construct the introductory class to do this, but for the second class in statistics, like the one that we teach on applied regression and causal inference, I do like how we do it in regression, other stories. I feel like we develop through the models in a way that makes sense. I try to do that in active statistics, but really, the most important part of teaching are the most basic classes, um, and there we're still working on how to do that.
Hmm. Yeah.
So I
Yeah.
don't know. I don't really know what the future is. I mean, there's a lot of statistics and machine learning methods out there, but a lot of basic concepts, of course, are still coming up no matter how you do it. Like issues of adjustment and bias and
Mm-hmm.
variation. So it's hard. It is hard to get it all, like feel like it's all in one place. It's frustrating.
Yeah. 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 No, I agree with that. I'm also asking the question because I'm really curious about it because I'm also personally a bit lost when I start thinking about these things. It's so huge, and for now, I don't have a clear uh organization in my head. Um, um, Maybe one last question for you, Andrew, before I let you go, because you've already been extremely generous with your time, and you know me, I could really interview you for like 3 hours, no problem. I have so many questions, but maybe what's next for you? What are your coming projects maybe in this coming year? What are you
Well,
excited
we're
about?
trying to well, Aki and I are trying to finish our Bayesian workflow book,
Mm-hmm.
and we'd like to do our advanced regression and multi-level models book. It would be fun to
Mm-hmm.
get recursion performed somewhere by some university theater group somewhere. I'm doing this research um, on combining multi-level regression and post-stratification and with sampling weights, which I think is really important. And I think also this could be useful for causal inference too, because people use weighting there. So that's probably the one project I'm most excited about from that direction. And then we're trying to write. I have I have a list. On my webpage, I have a list of published, unpublished, and unwritten research articles. So the unwritten is a list of like things that I want to do or write up. So there's a long list of that. I'm collaborating with an economist. We're trying to create a unified framework for causal inference for panel data, which really includes things like before after studies and regression discontinuities and difference and just regular regression, time series. I have a, like, just as a simple example, if you're doing linear regression, like you have a pretest, you regress, you condition on the pretest, you adjust for
Mm-hmm.
that. Really,
Yeah.
but if you have usually things in econ, like things are measured with error. And so you won't really want to regress on the pretest. What you really want to do is regress on the latent value that the pretest is a measurement of. Well, you can do
Mm-hmm.
that in Stan now. So now in Stan, you can write these models and do Bayesian models with latent variables. And I think there's some theoretical results to be done to like show how or see how these things like reduce to other things in special cases. It's a little related to my chickens paper that I did a couple of years ago, which was I really enjoyed. That's another story, though. That the chicken story is not in the active statistics book. I don't think it's like there's more stories. There's room for another 52 stories, I'm sure, in the future.
Yeah, for sure. Um, and the yeah, we should link to your chicken paper actually in the show
I
notes.
like the chicken paper. It's not the world's most readable. I mean, it's technical, but I like it. It's Bayesian. It's good.
Yeah, yeah. Is it? Are you referencing the one from 2021, or is that from before?
Yeah. Slamming the sham, a
Yes,
Bayesian model
exactly.
for adaptive
Yes.
adjustment with noisy control data.
Yeah,
Yeah, it's
I
published in
had that.
Statistics in Medicine, which like a journal nobody reads. But what can you do? I guess nobody reads any journal anymore, so that's fine, perhaps.
Yeah, so it's really good
Nobody
that you
reads
come.
anything.
Yeah, I mean,
Nobody reads anything. They're too busy reading stuff.
yeah, I mean, definitely that's why it's really good that you come on the show. And also that
Yes.
you write these books. I think it's extremely important because definitely the general public doesn't read paper. Um, I know I do
Mm.
read paper, but it's mainly because I have to for my job. I almost never read a paper by pleasure, because it's just like, yeah, um, the way it's written is just like so dry, and I really love a story, as you were saying. That's also why I
Yeah.
really love your writings in your books, in your blog, um, because it's always wrapped in a story and in a context, and the papers are mainly just, okay, this is the result, this is what we're doing, but it's just too drawing to me, and so I'm not reading that when I'm trying to just read for fun, But yeah, awesome. Well, thanks a lot, Andrew. I will. That being said, I will link to this chicken paper in the show notes for people who want to dig deeper. Thank you so much, Andrew, for again taking the time and being on this show. 2 patrons will have the chance of receiving for free a hard copy of your book, thanks to your editor. So thank you so much, Cambridge University Press. And in the show notes, you will have the links also to buy the book on the Cambridge University Press website. So go ahead and do that. You have a 20% discount active until July 15, 2024. The code is in the show notes of this episode, so definitely go there and buy Andrew's book. This one is really fun, and you can read it on the beach this summer, and then you'll have a lot of cool stories to tell your children or at the bar at night, so definitely do that. Thanks again, Andrew, and of course, welcome back on the show anytime you finish your 15 upcoming books.
Merci encore pour l'opportunité de parler avec toi.
Perfect. As you can hear, Andrew speaks very good French.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and follow the show on your favorite podcatcher, and visit learnbayesstats.com for more resources about today's topics, as well as access to more episodes to help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thank you so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.